Hi, this is the North American Math Contest Go Go Go. This week we are going to discuss about the squeeze theorem. So remember the definition of the theorem. So we are given three different functions on the same graph. The first one is fx. The second one is gx. And the third one is hx. And at some point, k, you see, fk is equal to hk, then gk must equals to both fk and this k. Well, this rule just seems like it's a common sense that we can predict it in 1 second. Yes. You know why this called squeeze theorem? Because it just looks like a squeeze sandwich. So that is why it also has another name called sandwich theorem. Let's do the first problem. The first problem is just help us to understand what is the sandwich theorem. So we know we are given two functions, hx and gx. Hx is equal to 5x plus 3, and gx is equal to 6x plus 1. We are required to find this, lim x to 2 fx. How are we going to do this? So we first find the solution of this, which this is equals to 5 times 2 plus 3 is 13. And then we find the answer of 6x plus 1, which is 6 times 2 plus 1 is also 13. So we know in this way 13 is less than fx is less than 13. So fx can only be 13, because if it is larger than 13, he will disobey with this agreement. If it is smaller than 13, he will disobey with this agreement. So therefore, he can only equal to fx is 13. Can I change the pointer? No. Okay. Okay. The previous example is just help you understand what it is. Now we are going to solve the real problem. When we first learn about limit, we realize that the sign thing are very hard because it changes. It changes like in the range of 1 to -1, and it's very hard to spot them. So it will be the first difficulty that everyone will find when they do study the calculus. Now let's talk about this. So for the 3 problems that I will be discussed about, these 3 problems all involves in an importance theorem, which is this. -1 is less than or equal to sine x is less than or equal to 1. Why? Because the function is in the range of -1 to 1. As sine equals to 19, it reaches its climax, which is 1. As sine equals to 270, it reaches its bottom, which is -1. So this means that we know that -1 is equal to sine x is equal to 1. Because it is hard to understand x sine x, so we first get the sine x. And after that, we time all 3 parts by x. So we know that since x approaches to 0, this is 0 and this is also 0. So we know this is going to be 0. Next problem. Find limit x to 0, x to the power x squared cos 1 divided by x. This problem is a bit tricky. How do we solve this? Well, so it seems like that we can't use it. I mean, first we know that cos x is equal to -1 is to 1, right? So after that, we can determine that cos 1 divided by x is larger than -1 and smaller than 1. How are we able to determine it? Because cos z, remember cos z, where z is in any value, the cos z will always be larger than -1 and smaller than 1. Because cos is similar as sine, at cos 0, the cos reaches its maximum point, which is 1. At cos 180, it will reach its smallest point, which is -1. So we first get this, right? Get this statement. After that, we time the three sides by x squared. So we know that x squared is equal to 0. So we know that x squared cos 1 divided by x must be also in the range of 0. So therefore, we get that x squared cos 1 divided by x is 0. Example 3. Find this. Lim x to 0. X squared sine 1 divided by x divided by sine x. Well, this involves several steps of the sandwich theorem, so I give you 20 seconds to think about this. "20 seconds is up. Now let's see my solution." Well, it may seem like it is so hard, right? Well, so the breakpoint for this problem is sine 1 divided by x sine x. Let's first state this. State the squeeze theorem. We know that sine x is less than or equal to 1 and sine x is larger than -1 when x is any value. This is a basic fact, right? So after that, we need to use the first squeeze theorem to divide this statement. Negative sine 1 divided by x is less than or equal to sine 1 divided by x divided by sine x less than or equal to sine 1 divided by x. So we know that since x, we know that sine x has the smallest value of -1 and the largest value of 1. So we just assume sine x is -1. So therefore, the smallest value will be sine 1 divided by x divided by -1, which is negative sine x. The largest one, we assume sine x is 1. So we know that sine 1 divided by x divided by 1 is going to be sine 1 divided by x. This is a bit tricky. So we actually define the range of sine 1 divided by x. So we can multiply x squared. So why do we multiply x squared? Because if we multiply x squared, then it will become the original function, which is x squared sine 1 divided by x. So we know that we can determine its range by negative x squared sine 1 divided by x less than or equal to x squared sine 1 divided by x divided by sine x less than or equal to x squared sine 1 divided by x. So we can get it into a less complex formula. So we know that, but why can't we just get the answer? I mean, plug in the x equals to 0 directly, because there is 1 divided by x. If we do it directly, then it will cause undefined. Well, then the problem will be the problem that is difficult, that has a difficulty like this. So let's come back. So we know that based on the statement we get here, cos 1 divided by x is equal to 1, larger than 1, and larger than -1 and less than 1. So it is same that sine 1 divided by x is less than or equal to 1 and larger than -1, or equals to, sorry. So we get this statement. So we apply another squeeze theorem again, right? This is this, which this is a common fact. But we want to get this and this, right? So let's try both, since it has negative and it has positive. So let's first calculate negative. We time both sides by positive x squared. So this means it will be larger than negative x squared and will be smaller than x squared. If we time it by negative x squared, then it will be x squared smaller than x squared sine 1 divided by x smaller than negative x squared, which will be equivalent to this formula, which is negative x squared less than or equal to x squared sine 1 divided by x less than x squared. Oh my god. Well, now we can substitute x is 0, right? because here it won't have any trouble like undefined or something. So here we can just substitute the negative x squared, which is 0 divided by x squared sine 1 divided by x less than 0. And here we can get this. So we know that we know that in this case 0 is less than or equals to this is less than or equal to 0. So we can simplify the formula to this. So therefore we can finally get x squared sine 1 divided by x divided by sine x is equals to 0. So here the difficult part of this problem is that you need to use 2 layers of squid theorem. And these 2 layers are a bit intricate to find. Yes. And here we come to the end of this chapter, and I hope you have learned a lot. See you next week. Bye!